Andromeda is rushing towards us at 110 kilometers per second, a speed that could take you from New York to Los Angeles in just 40 seconds. Yet, the galaxies are so impossibly far apart that the full impact won't begin for another 4.5 billion years. This cosmic dance of destruction and creation is already underway, defining our galaxy's ultimate fate. Prepare to discover what truly happens. Andromeda, our massive galactic neighbor, currently sits 2.5 million light-years away from the Milky Way. Its gravity is already tugging at our galaxy, setting the stage for an unimaginable cosmic event. This future collision will not be a sudden crash, but rather a slow gravitational waltz spanning billions of years. Prepare to discover what truly happens when two spiral giants become one. Astronomers predict that the first major pass-through of Andromeda and the Milky Way will occur in about 4.5 billion years. This initial encounter will stretch and deform both galaxies with immense tidal forces. However, stars themselves are highly unlikely to physically collide, given the immense distances between them, even in a crowded galactic core. Instead, gas clouds and galactic structures will undergo dramatic transformations. Number 1. The Antennae Galaxies, two spiral galaxies locked in a spectacular collision over the past 100 million years. Located 75 million light-years away in the constellation Corvus, they offer a vivid preview of our own galactic future. You can witness their ongoing merger, with millions of new stars igniting in brilliant blue clusters. This celestial dance illustrates the violent beauty of galactic metamorphosis. During their collision, the Antennae Galaxies' dust and gas clouds compress violently, sparking immense bursts of star formation. These starburst regions are thousands of times more active than our Milky Way's current star-forming rate. Such intense activity sculpts new luminous nebulae visible even across millions of light-years. This process will largely replicate in the Andromeda-Milky Way event. Gravitational forces in the Antennae Galaxies have already ripped huge streams of stars and gas from both systems, forming long, tidal tails. These luminous arcs extend hundreds of thousands of light-years into intergalactic space. Their stretched and contorted forms demonstrate the immense power of gravity during such a close encounter. You are seeing the raw, destructive power of colliding cosmic giants. The two galactic cores of the Antennae Galaxies are spiraling closer, destined to merge into a single larger supermassive black hole. They are currently separated by about 20,000 light-years, still actively consuming material. This center region is incredibly chaotic, with dust lanes obscuring the merging nuclei. The entire structure will eventually settle into a giant elliptical galaxy. Observations of the Antennae Galaxies reveal dense knots of material indicative of future globular clusters and star-forming regions. This system is a living laboratory showing us how galactic mergers redistribute matter and energy. Their future will involve the complete assimilation of both spirals into one new, majestic but likely less structured galaxy. It's a preview of Andromeda's distant future. The two black holes in NGC 62240 are just 3,000 light-years apart, incredibly close by cosmic standards. They are locked in a gravitational death spiral, slowly losing energy through the emission of gravitational waves. Scientists calculate that they will merge into a single colossal supermassive black hole in another few hundred million years. This event will shake the very fabric of space-time. The dual black hole system in NGC 6240 is still surrounded by incredibly active regions of star formation and turbulent gas. These swirling clouds of material are being funneled towards the galactic center, fueling both black holes. Such intense activity often results in powerful jets of particles escaping the galaxy. This energetic feedback mechanism dramatically influences galaxy evolution. The final merged black hole in NGC 6240 will have a mass billions of times that of our Sun, becoming the dominant gravitational force in its new galaxy. This colossal entity will continue to grow by accreting gas and merging with other black holes. Such supermassive black holes are vital to understanding How galaxies evolve over cosmic time. Our own Milky Way will host such a behemoth. Number 3. The starbursts of Antares A. This peculiar galaxy is the result of a past merger, showcasing massive star formation triggered by colliding gas clouds. Antares A, only 11 million light-years away, is an active galactic nucleus with vast quantities of cold gas. Its energetic jets and intense star formation illustrate what happens when galaxies merge. This gives us clues for Milky Way's future. Despite the collision name, direct stellar impacts between the Milky Way and Andromeda stars are incredibly rare. The vast emptiness of space means stars are separated by light years, even within a galaxy. You're more likely to win the lottery multiple times than for two specific stars to physically hit each other. Instead, their orbits will be radically reshaped by gravity. What will collide are the enormous clouds of gas and dust within both galaxies. When these diffuse clouds smash into each other at high speeds, they compress and collapse. This compression triggers intense, widespread bursts of new star formation across the merged galaxy. You'll witness a spectacular display of cosmic fireworks across the newly forming Milky Way. Some stars, caught in the extreme gravitational turbulence of the merger, will be flung out into intergalactic space. These runaway stars will wander eternally through the dark voids between galaxies. Others will find themselves in radically different orbits around the new galactic center. Your perspective of the night sky would be utterly transformed during this era. Over billions of years, the vibrant blue spiral arms of Andromeda and the Milky Way will largely fade and become redder. The intense starbursts consume most of the available gas and dust, leaving little for future star formation. This process leaves behind a galaxy dominated by older, redder stars. The new Milky Way will be a redder, more sedate elliptical giant. Number 4. The elliptical future of Milky Way. The combined Andromeda and Milky Way will eventually form a single, massive elliptical galaxy. This new entity has been affectionately nicknamed Milky Way by astronomers. Its structure will be far less organized than the spiral galaxies we know today, lacking prominent arms. You live in a cosmic city unlike anything seen before. Unlike the flat rotating disks of spiral galaxies, Milky Way will be a more spherical, centrally concentrated structure. Stars within it will follow highly eccentric, chaotic orbits rather than the orderly paths of a spiral. The familiar beauty of our Milky Way's spiral arms will be a distant memory. This represents a fundamental shift in our galactic address and appearance. The long-term evolution of Milky Way involves a gradual settling, with star formation dwindling over cosmic eons. The galaxy will become a relatively stable but less active giant elliptical. It will dominate the Local group, with smaller galaxies orbiting it. This final form will persist for trillions of years, a testament to the power of galactic evolution. This grand cosmic collision reminds us of the universe's dynamic and ever-changing nature. Galaxies are not static islands, but evolving entities, constantly interacting and reshaping each other. The Milky Way and Andromeda's future is a story written in gravitational waves, starlight, and the immense canvas of space-time. It's a reminder of humanity's small place in an epic cosmic ballet. What future do you imagine for our galactic home after Milky Way forms? Share your thoughts in the comments below. If you found this journey through cosmic time awe-inspiring, please like this video and subscribe for more mind-bending explorations of the universe. Join our community as we unravel the universe's greatest mysteries, one revelation at a time.